Hello student, how are you? I think all of you are okay and all of you are studying very seriously. Welcome to our YouTube channel Unique Science Zone. I discussed first part of this chapter set. Today I am going to discuss later part of this chapter which contains cardinal number of a set, subset, proper subset, superset, power set, singleton set, void or empty set, universal set, finite or infinite set, denumerable set, non-denumerable set, counting set, and so on. Okay, so first, what is cardinal number of a set? Cardinal number of a set is total number of elements of a finite set. Here I have considered only finite set, but we can count cardinal number of infinite set also, but here I have considered only finite set. So what is cardinal number of a set? Cardinal number of a set is total number of elements present in that set. So for any set A, cardinal number of this set is denoted by n of A. Say if we consider A equal to 1, 2, 3, 4 and 5, then cardinal number of set A will be Na and Na equal to 5. Next, different types of set. In different types of set, we will read what is singleton set, what is void or empty set, what is finite and infinite set, what is subset, what is power set, what is proper subset, what is superset, what is equal set, what is equivalent set, and what is universal set. First one is singleton set. What is singleton set? A singleton set is a set which consists of only a single element. Only a single element. Say let B be any set and B equal to x such that x greater than 1, less than 3, and x belongs to blackboard of n. Since between 1 and 3 there is only one natural number which is 2, so B will be 2, so B is a singleton set. Here I have given another example, x such that x belongs to W and x square equal to 4. So x square equal to 4 means x will be plus minus root over of 4. That means x will be plus 2 and minus 2. But x, here x belongs to W, so here x will be only 2. So this set contains only one element, that is 2. So it will be also a singleton set. Next one is void set or empty set or null set. Void set, empty set or null set. What is void set or empty set? So a set is said to be empty or void if it has no element. it is denoted by Greek alphabet phi. Greek alphabet phi. So if we consider any set, say x, say let A be a set and A equal to x such that x greater than 5 less than 6 and x belongs to n, that means blackboard of n, that means x belongs to natural number. Now see, between 5 and 6 there is no natural number, so here set A will be a null set. That means we can write set A equal to 5. Next one is, here I have given another example. Say let A be a set where A equal to x belongs to n and x greater than 1 and less than 2. Now see here, between 1 and 2 there is no natural number, so set A will be here a null set, so A will be actually 5. Next, finite and infinite set. What is finite set? A finite set is actually a set which contains finite number of elements, but this is one type of definition, but in proper way if we want to say, then it will be like that a set is said to be finite if the number of elements contained in the set can be counted and the counting process has an end. That means finite set are those set whose elements can be counted, or we can say the next definition also, a set is said to be finite if it contains specific number of elements, but better if we write or if we say the first definition. Now say let B equal to 1 2 3 4 5, so B contains finite number of elements, so set B will be a finite set. Or if we consider another example, say set of vowels V, A, E, I, O, U, so here set of vowel contains 5 elements, so it will be also a finite set. Next, what is infinite set? A set is said to be infinite set if the number of elements contained in the set cannot be determined by counting process. Cannot be determined by the counting process, ordinary counting, and the counting process has no end, and the counting process has actually no end. Or we can say in this way also, and a set is said to be infinite set if it contains infinite number of elements. Now if we consider a set C equal to 1, 1 by 2, 1 by 3, 1 by 4, it will be an infinite set since it contains infinite number of elements, and its element cannot be counted by ordinary counting, so it will be an infinite set. Now infinite sets are two types, one is denumerable set and another is non-denumerable set. What is denumerable set? An infinite set is said to be denumerable if the properties defining the set allow one to arrange its element in the form of a sequence. Means if we can determine elements of a set by ordinary counting, and if we can arrange the elements of a set in the form of a sequence, then we can say the given set is a denumerable set. Say if we consider set of natural number, that is blackboard of n, or if we consider set of whole number, that is blackboard of w, set of integers, these are actually denumerable set. Why these are denumerable set? Since these sets or elements of the set can be counted, that means we can count elements, and elements of the set can be arranged in the form of a sequence, means we can arrange either by descending order or by ascending order. So set of natural number, set of integers, that is z, set of whole numbers, all of these are denumerable set. Second one is non-denumerable set. What is non-denumerable set? Non-denumerable set is also an infinite set, but here elements of this set cannot be counted by counting, and elements of this set cannot be arranged in the form of a sequence. So that means first we cannot count elements of this set by ordinary counting, and second one, we cannot arrange elements of this set in the form of a sequence, that means in ascending or in descending order. Say if we consider a set, say suppose A be a set where a equal to x such that x greater than 1 and x greater than 2, and this x belongs to R. First one, if I ask how many elements are there in this set, first one, it will be infinite, means we cannot count. There are infinite number of elements in this set A. Now can anyone count elements of this set? No. Since between two real numbers, see here 1 and 2 both are real numbers, and we know standard property of real numbers that between any two real numbers there are infinitely many real numbers. So we cannot count elements of this set. Say 1 and 2, so between 1 to 1 plus 2 by 2, that is 1.5. This will be a real number between 1 and 2. Again 1 plus 1.5 by 2, this will be another real number lying between 1 and 1.5. Again 1.5 plus 1 by 2, this will be another real number lying between 1.5 and 2. So in this way we cannot count the elements of the set, so it is actually a non-denumerable set. See, set of natural number and this set both are infinite set, but in set of natural number we can count elements of the set, that is 1, 2, 3, 4, 5 by ordinary counting. Next one is countable set and non-countable and uncountable. What is countable set? A set is said to be countable set if it is either finite or denumerable. That means if a set, if it is either finite or denumerable, then set is called countable set. Means if we consider any finite set like say 1, 2, 3, it will be also a countable set. Or if we consider set like that, the set of natural number, set of whole numbers, set of integers, it will be countable set. Next one is uncountable set. What is uncountable set? A set is said to be uncountable if it is non-denumerable, and we have already read what is non-denumerable set. So any non-denumerable set is always an uncountable set. And here I have given two example of countable set, and here I have given one example for here I have given two example for countable set, and I have given one example for uncountable set. Say b equal to x such that x greater than 1, less than 2, x belongs to R. So it will be actually an uncountable set. Next one, subset. What is subset? Say suppose A and B be two set. If every element of A is an element of B, then we can say that A is a subset of B. And if A is a subset of B, then we write it by special notation A subset of B. This notation is used for subset. In last class we have already read this notation in a tabular representation. So for subset we use this symbol. Say here if we consider two set A equal to 1 2 3 and B equal to 1 2 3 4 5. Now see, every element of A, that is 1 2 3, are element of B, and there are two elements 4 and 5 which are not in A, so A is a subset of B. Next one is power set. What is power set? Power set is set of all possible subset of a non-empty set. It's called power set. So power set, this is actually a collection of all possible subset, or we can say family of all subset of a set. And for any set A, power set of A is denoted by P of A. Now say if we consider any set A equal to 1 2 3, then how many subset can be formed from this set A? First, empty, we can form a set without considering any element. So in this case it will be 5. That is the first one. Second, considering 1 2 and 3 separately, we can form 3 singleton set. Considering 2 element at a time, that is 1 2 2 3 and 1 3, we can form another 3 subset. And considering the whole, that means 1 2 3, we can form another set. That means we can form 1 2 3 4 5 6 7 8 subset. So PA will be 5 1 2 3 1 2 2 3 1 3 and 1 2 3. So these are actually family of subset. Now here I have considered a set which consists of 3 elements, and here I have got 8, that is 2 to the power 3 that means 8 subset. So for any set A, or if a set A which consists of n elements, then its power set contains 2 to the power n elements. And here in note I have written that if A is a finite set having n elements, then its power set PA contains 2 to the power n elements. Next one is proper subset. What is proper subset? Says suppose A and B are two set such that every element of A is also an element of B. That means every element of B is also an element of A. That means B is a subset of A, and there exists at least one element in A which is not in B. That means then we can say B is a proper subset of A, and if B is a proper subset of A, then we can write B is a proper subset of A, and for proper subset we use this notation. Remember, for general subset we use this notation, and for proper subset we use this notation. Now for example, if we consider say A equal to 1 to 3, set A equal to 1 to 3 and set B equal to 1 2, then B 1 and 2 both are also element of set A, and there is an element 3 in set A which is not in B. So in this case B is a proper subset of A. Next one is superset. Superset is actually a special type of set, and when we can define superset, say if suppose A and B are two sets such that B is a proper subset of A, then we can say A is a superset of B. That means we can define only those cases superset if proper subset exists. That means here if B is a proper subset of A, then A is a superset of B. Next one is equal set. What is equal set? Two sets A and B are said to be equal if their cardinal number are same and both contains same element also. Or we can define in this way also, if A is a subset of B and B is a subset of A, then A equal to B. So if we consider two sets, or two sets are said to be equal set if their cardinal number is same or equal and both contains same element also, then we can say two sets are equal. Say let A equal to 1 2 3 and B equal to 2 3 1. So obviously A equal to B, since both cardinal number of both the set in A is 3 and also both contains same number of elements. So here A and B both are equal set. Next one is equivalent set. What is equivalent set? Two sets are said to be equal set if their cardinal number same. That means here if cardinal number of two sets are equal, then we can say that these two sets are equivalent set. Say if A set A equal to 1 2 3 and set B equal to ABC. See here, cardinal number of set A 3 and cardinal number of set B, it is also 3, but both set contains different elements. Since their cardinal number equal, so these two sets are equivalent set. Now that means every equal set are equivalent set. Since equal set means their cardinal number same, but equivalent set means this is not an equal set. That means we can say every equal set is an equivalent set, but equivalent set is not necessarily an equal set. Next one, universal set. What is universal set? Universal set actually we consider in the discussion of set theory, and universal set is considered on a particular context, only a particular context. If context vary, then universal set will also be vary. Say if we, so universal set, so there is always happens to be the set that contains all sets under consideration, that is it is a superset of each of the given subset. That means in any discussion, if we consider different types of set of same kind, then superset of all this set will be the universal set. It will be more clear if we consider an example. Say just think we have considered two-dimensional geometry. In two-dimensional geometry, we can consider different types of set, but here superset of all of this subset which we have considered for two-dimensional geometry, it will lie on xy plane. So here all the points lies on the xy plane will be the universal set. Or we can say we can consider another definition. Say suppose in any discussion we have considered only positive subset of positive natural number. Subset of positive means 1, 2, 3, or b equal to 10, 11 and 12. C equal to another set, say 40, 50 and 60. Now see, A, B, C, all of these are subset of natural number. So here set of natural number will be our universal set, and in general universal set is denoted by U, or sometimes it is denoted by S also. Okay, so thank you. I think maximum of our student have understood this lecture, and if anyone have any doubt, they can ask their doubts through WhatsApp. So thanks for watching, and if you are benefited, then please subscribe our channel and press the bell icon. Please like, share and comment in our videos, and once again thanks for watching.